Hi guys, it's Mr. Baragon. See, I'm there. I'm playing around with different technology, but let's get back to the math here. So if you looked at the first problem of the first video, remember we're rewriting these in inverse form, right? So we already did A and B. We got to remember the meaning of what a logarithm is. A logarithm is the inverse of the exponential function, right? So what we're doing is we're writing all of these as the inverses. So if it's a log, you're going to write it as an exponent. If it's an exponent, you're going to write it as a log. So let's go with C. Now this is a little different. A and B were pretty straightforward, right? We have log base 6 of x plus 1, okay? All right. Well, here's the problem with this one. You have that plus 1, so it's not that easy of a change. So we're going to have to change it, right? But it's not going to be as simple as you guys remember. Okay, so remember, if you don't remember what the meaning of log is written as an exponent. Here's my base, right? Here's my base. So that means my base is going to be 6. And the the solution to a log is your exponent. So this would be 6 to the y, and then it should be equal to x plus 1. That would be your solution now. Here's the thing, you guys. We want to get in this case, we're going to try to get the x by itself because remember, we're going to switch the order. So these two, we're going to switch the y to the x and the x to the y. And we want to get the y by itself. Remember, that's what the instructions. We want to get y by itself. So I actually have to subtract 1 on both sides. Okay, minus 1, minus 1. These are going to cancel out. But here you can subtract 1 from 6 to the y, right? So we're going to rewrite it just as an expression. 6 to the y power minus 1 equals x, okay? But we want to write it as inverse. So that means we're going to actually switch this. So we're going to switch the variable. So instead of writing it as 6y, it's going to become 6 to the x power minus 1 equals y. And then let's just rewrite the order. Y equals 6 to the x minus 1. That is my inverse, okay? So it's the inverse to this first problem, right? So remember, what are we doing? We're switching the order. We're switching the order, and also we switch these variables, right? So y and x are switching, and it becomes x, and this becomes y, right? And then we just write it in order so that we have the y equals first, and then the rest of the problem, okay? So again, this is the inverse of this original one, the first one, right? This is the inverse, the one written down here, y equals 6x minus 1. And you could check this using Desmos. You guys can check it using Desmos. And remember, how do we check if the graph is different, right? I mean, how do we check graphically if they're inverses of each other, okay? Look back to the videos we did. I did the problems in 5-56 is where we answered that question, okay? So let's go over the very last one. And if you guys are noticing, there's a pattern, right? We have to remember the order of how do you rewrite the order from an exponent to a log? So let's switch the order, right? I mean, let's switch it from a exponent to a log. So the base, right, is 5. So we write it as log of 5. And then this is what your solution would be, the log of that you're getting, right? And then the exponent is actually the solution to the log. So now we have this, but if you notice, there's a 2 here. So what we're going to do, we actually have to divide by the 2. If we divide by the 2, then we get that variable by itself. So that means, let me write it over on this side. Let me use a different color. So we're going to be left with log base 5 of y over 2 equals x, okay? Now the last thing I have to do is rewrite the order, right? So we're going to rewrite it as log base 5 x over 2 equals y. And then just rewrite that order, you guys. Write it with a y first, and then